Hi, in this video, we will be discussing electronic configurations. For us to understand how electrons are arranged in an atom, we will have to start from the basics. Here are a few key definitions that we need to familiarize ourselves with before we begin. The first term will be principal quantum shell. This is the main energy level of an atom. In order to make this clearer, we can look at this diagram. Each sphere represents a different principal quantum shell. We can label them as n equals 1, n equals 2, and n equals 3, where n is known as the principal quantum number. These principal quantum shells will be occupied by electrons. The higher the energy level of the quantum shell, the further away the electron is from the nucleus. In order to find the maximum number of electrons that can be found in each quantum shell, we use the formula 2n to the power of 2, where n is the principal quantum number. The second term that we will need to know will be subshell. Quantum shells can be further broken down into subshells. There are 4 different types of subshells: S, P, D, and F subshells that can be found in the quantum shells. These subshells differ slightly in their energy levels. Energy of the subshell increases in the order S, followed by P, followed by D, and finally F. The third and last term that we will have to familiarize ourselves with would be atomic orbitals. Within each subshell, there are atomic orbitals. To put it simply, we can say that electrons occupy these orbitals, where each atomic orbital can hold up to a maximum of 2 electrons. Each subshell can have 1 or more atomic orbitals. The S subshell has 1 orbital and can hold up to 2 electrons. The P subshell has 3 orbitals and can hold up to 6 electrons. The D subshell has 5 orbitals and can hold up to 10 electrons. And lastly, the F subshell has 7 orbitals and can hold up to 14 electrons. Note that orbitals within the same subshell will be degenerate. This means that they have the same energy level. Also, atomic orbitals within the same subshell will have different orientations in space. Since all of these might sound very confusing, let me do a brief summary with this table. So, in the first principal quantum shell, there is a 1s subshell, which has 1 orbital. Hence, this principal quantum shell will have 2 electrons in total. In the second principal quantum shell, there will be a 2s subshell and a 2p subshell. The 2s subshell has 1 orbital, while the 2p subshell has 3 orbitals. Hence, the second principal quantum shell has 8 electrons in total, since it has 4 atomic orbitals. Have you noticed any pattern yet? In the third principal quantum shell, there will be a 3s subshell, a 3p subshell, and a 3d subshell. The 3s subshell has 1 orbital, the 3p subshell has 3 orbitals, while the 3d subshell has 5 orbitals. In total, the third principal quantum shell will have 18 electrons, since it has a total of 9 atomic orbitals. In the A-level syllabus, we will be mainly tested on the S and P subshells. In each S subshell, we can find 1 s orbital. The s orbital is spherical in shape, and the size of the s orbital increases with principal quantum number. Now, let me draw out the 1s and 2s orbitals. Do note that it is stated in the syllabus that you should know how to draw the s and p orbitals. To draw the orbitals, I will first have to draw the x, y, and z axis. These 3 axes represents the orbitals in 3D. So, this is how the 1s orbital will look like. We represent the 1s orbital by drawing a sphere. For the 2s orbital, we have to draw the axis again, but this time, we have to ensure that the sphere that we draw in the 2s orbital is of a bigger size than that of the 1s orbital. Now, for the p subshell, In each p subshell, we have 3 p orbitals. All 3 orbitals are dumbbell in shape and differ in spatial orientation. And lastly, they are all degenerate. Now, let me draw out the 2p orbitals. Similarly, we start by drawing the x, y, and z axis. As the atomic orbitals differ in spatial orientation, we will draw a dumbbell along each axis to represent each atomic orbital. Importantly, do remember to label all 3 p orbitals. Moving on. Now that we have learned how electrons are arranged in an atom, we will need to learn how we can predict the electronic configuration of atoms. The first thing that we will need to know would be the Aufbau Principle. This principle states that electrons will fill lower energy atomic orbitals before filling up higher energy ones. If we look at this energy level diagram, we can observe that different atomic orbitals have different energy levels. When electrons fill up these orbitals, they will always occupy the orbitals in order of energy level from the lowest to the highest. However, not to worry. There is no need for us to memorize the energy levels. In order to deduce the relative energy levels of the orbitals, we can use a simple method. Firstly, we will need to list down all the orbitals in this manner. Next, we will draw diagonal lines across the orbitals, starting from the 1s orbitals. The final diagram should look like this. The order of which we drew the diagonals will represent the increasing energy levels. Hence, we can easily tell that the energy level increases from 1s to 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on and so forth. Note that electrons will fill up the 4s orbital before the 3d orbital, given that the 4s orbital has a lower energy level. This is a common mistake that many students make. So, in this video, we learned about the principal quantum shell, subshells, atomic orbitals, and Aufbau Principle. If you found this video helpful, I will be grateful if you can give a like and subscribe. In the next video, we will learn about how we can present electronic configurations with the Electron-in-box diagram.